So we had this question about selecting the output that you would expect to see when you execute the following, which is print station ID plus station ln. As you might remember, station ID is a whole decimal or whole number. It's a integer value. Station ln is a decimal value. And these two data types are perfectly compatible. You're just adding two numbers together. Python's like, hey, no problem. No need for a type error here. No need for a syntax error or anything like that. When we print this, what we would get would be this second option here, 132.334.96. And if I look here, that was the top choice for those of you who answered this question. It's just adding the two numbers together. I don't remember, I think it was like 132.310 or something like that, and then 24.96. So that's how you get the sum of those two numbers. So just because we have different data types doesn't automatically mean they're not compatible with each other. In our other case here, we had station name, which is a character string, station ID str, which is a character string as well. And when you add these two together, this is where that string concatenation happens. So you get the first string and the second string, and they just get merged together into one longer string. So in this case, station name is first here, Helsinki Kaivopuisto, and then this station ID str is added to that second. And so again, choice number 2 here is the one that we would expect to see. And just quickly looking at the responses, that is also the most common response here. So there's no type error because we have a string plus a string. And the plus thing might seem a little bit weird, but it's fine to do those kind of, like, certain mathematical operators work with character strings. Division doesn't, because I don't know if you can imagine a situation where dividing some character string by another character string would make any sense. It kind of doesn't, but adding them together is just a quick way to just merge together two different character strings. So that one's totally fine. Any questions about the two questions there? All right. So I'm not going to go through the next stuff in the lesson in too much detail. I'm going to try to keep sitting back because it seems like it's not quite as ringy if I sit further back, but I can't see my keyboard very well then. But we had this thing about combining our text and numbers. You can find at least an example of how to do this on the linked materials for this lesson in the book materials online. But then there's this formatting text and numbers thing, and this is actually pretty useful. This is where we can introduce the idea of f-strings. So I'll show you one example of how to use an f-string because we'll use them during the class. It's, I think, sort of short for format string. And it's one way in which we can take things that are text, like character strings, and numbers, and even other data types, and put them together without even having to convert from one data type to another. So let's imagine that we wanted to print out something about our Helsinki Kaivopuisto station, like its station name and maybe some temperature, which here is just given as this 18 point blah, blah, blah number. The way we would do that with an f string is we can define something like an info text, which we'll just call our variable here. Say info text equals. And the key thing to an f string is you're going to have parentheses, or not parentheses, sorry, quotation marks like you normally would, but you're going to have a lowercase letter f at the beginning of the quotation marks. That's indicating that this is an f string and Python's going to do something special with it. So we could say, for instance, the state or the temperature, and let's just call it temp, at, and then you've got to make these curly braces here. So hopefully you know how to do that on your computer. I guess for those of you who happen to be using a Mac, it's like Option Shift and then the parentheses, like the 8 and 9 key, or something similar, I think, in Windows, but at least for Mac users who are using a Finnish keyboard, that's what it looks like. And inside the curly brackets, you're going to put the name of a variable. So this now we could put in our station name, spelled correctly, of course. So we could say the temp at station name, and then we can say outside of the curly brackets, ID, and then we'll give in here our station ID. Station ID. I'm putting parentheses here, not to do anything kind of like special, but simply that we want to have the station ID in parentheses in the text string that gets generated. Is, and then we're going to put one more set of curly brackets, temp, and then colon, point to F, and then let's say degrees Celsius. Something like that. You don't have to put this in exactly as it is in terms of the text here, but we're making this info text string, and then we'll print it. Let's see what the print statement does, and then we'll go back to seeing what this F string looks like and how it works. So I run this cell now, and when I print out info text, I get the temp at Helsinki Kaivopuisto, and then here's our station ID, is 18.57 degrees Celsius. So some stuff has happened here. First off, in our F string, we are able to put in values from variables by putting them inside these curly brackets. You can see, for instance, here, station name, when we print this out, is substituted by the value that was assigned in the variable station name. Here then, the ID, again, same thing happens for station ID, because station ID is inside the curly braces. It substitutes the value from that variable into our text string here, and notably, we did not have to convert from an integer to a text string to be able to do it. So this is part of the benefit of using these F strings, is it will convert things automatically for us to be able to work in a text string, because an F string knows that what you want to do is produce some kind of text. So it will convert station ID automatically to be able to be displayed here without using, for instance, the str function. Then we got this funny looking one, where you can see we have the variable temp that was defined up here, referenced inside curly braces, that's fine. But then we have this colon and the point to F. So here we're actually adding in, by having this colon character, a specifier to tell us how do we want to format this number. In this case, by having the point 2, we're saying we want it to be a decimal value with 2 digits of precision, and then F is indicating that it should be displayed as a floating point number. There's a lot of stuff you can find in terms of other examples online about how to use F strings. There's other kinds of string formatting stuff that can be done. But the most common one by far is to do like point, some number, and then F as a way of rounding off the numbers. And you'll notice here that it says 18.57. Our original number was 18.567, blah, blah, blah. So it did actually round that to the nearest hundredth, if you want to refer to that position in the numerical representation. So it does round the value to the nearest whatever number of precision you want to give. So if we change this, for instance, to be 0.4F and printed it again, you'd see we get 4 digits of precision. In this case, it also rounds it, as would be expected. If you give 0.0F, it just rounds it to the nearest whole number. So 0 values after the decimal place means you're just talking about whole numbers. You can also change the letter that's here. If you wanted to, you could do 0.2E, which will use scientific notation. So now you can see it's 1.86E plus 0.1. We've now made it perhaps a little bit less obvious what number we're referring to here, but if you're really familiar with scientific notation, you might recognize that that's 18.6. But that doesn't really make a lot of sense to do that kind of formatting in this particular instance, because what we're looking at is a number that's a pretty, like, it's not super big or super small, so why use scientific notation? What's the one for percent? Is it just the percent sign? Yeah, so if you put a percent sign there, it will automatically convert your number to a percentage. There's a few other like string formatting things you can do there. But again, the most common one is to do point, some number, and then F to do floating point representation. Because look, let's be honest, we don't need to represent our temperature with 8 digits of precision. Probably even 2 is more precise than what we need, but depends, of course, on what you're working with. If you're some particle physicist, then you need like, whatever, 32 digits of precision. That's fine. But for us, if we're just talking about like how warm it is outside, practically speaking, if I was telling, some family member what clothes to put on at 18 degrees or 19 degrees is plenty, enough information to tell you that it's, how to be prepared. I don't know if you can put in negative numbers. No, you can't. And you can't put in decimal values there. Yeah. So anyway, you can play around with the example if you want, but it's an easy way to format strings without having to convert things. You'll see lots of examples in the lessons that come after this. Now that we've introduced F strings, we're going to use F strings in the other lessons, so you get practice typing them in. By comparison to other ways of formatting numbers historically in Python, these are super easy to use. And you can find a bit more information about using F strings in the lesson materials. You can also find examples of using the old dot format approach, which is actually quite similar in some respects to how things work with F strings, but a little bit more clumsy. And if you really want to keep it old school, you can use the percent operator, which is really awkward, I would say. But the reason we show you these two is that if you go looking around for stuff online, you are likely to find examples of using dot format and using the percent operator for formatting. So it's good just to know what they are and how they work. There are still some pieces of software that I use that are like the current releases using this percent sign formatting. And it's for historical, like they don't want to break old versions of things, so they still support this. But I find it really confusing to use the percent formatting, especially when F strings are so much easier to read. At the end of the lesson, there's also some stuff about manipulating character strings. I think we'll skip over it because we won't use this in the exercise for this week, but you're welcome to look through it and go through the rest of the lesson materials if you want. Essentially, it talks about things like how to go from some text string that looks like this initially, where we have these different stations, and to strip it down to get some output text that has, for instance, capitalized only the names that are after the word Helsinki in here. So it talks about how to split strings. So if you have a character string, you can split based on a certain character into separate pieces. For instance, if you have comma separated values in a character string, it's often a useful thing if you want to make a Python list to split using the comma character, which then will take everything that's separated by a comma and make it its own value in a Python list. Also talks about how to slice strings, which is just selecting parts of a character string, and then how to do some text replacement, changing cases and things like that. But that's something we'll leave for you if you want to have a look at it. It's kind of extra material for you to be able to go through. I think that's our Python lesson for now. Are there any questions? Okay. If not, let's jump back here to our lesson for today, because we've got a few things to go through about version control, most importantly, telling you how to get a copy of your exercise materials to be able to work with it using version control in this week's lesson. So we'll start with just an introduction to what the idea is here. I might go through this a little bit quickly just because I want to make sure we have plenty of time to have everybody set their GitHub accounts up to be able to work with the exercise materials this week. But in essence, version control is meant to solve a couple different problems. So one of them is illustrated here in the cartoon of looking in someone's documents folder and finding all of these horribly named files. And the other is this comic from the PhD comics titled Final.doc, which I think all of us have been through this experience on one level or another of thinking you finalize something and then you have a revision and then you get comments and then corrections and then this, and eventually you end up with this ridiculously long file name because you're keeping track of the previous file by renaming it, which is one way in a sense of doing version control, but it's not a very systematic way of tracking versions of documents. But when you're left to your own devices, this is typically what people will do. I know certainly when I get things over email, I just add my initials to it and then comment and send it back to the student with comments. The idea, though, is that this document is a sort of evolving thing, and it would be nice if final.doc just kept its name and the changes were somehow able to be tracked. And that's the idea with what version control does. So there's some text here that I won't go through all of it, but essentially if you have a document, for instance, it could be a Word document like this, and you add some things to it, you maybe add in this line that's highlighted in green as another line of text in your document, and then you add in some more lines later that are added to the document. The initial document started out like this, and then you can see these things have been added. The basic idea is that this is the same document, you're just modifying it. And so rather than renaming it to keep track of the changes, what would be nice is to know what changed every time you added something to the document. And version control is a kind of system, like a software system basically, that allows us to keep track of specific changes to specific documents without having to rename them every time. In fact, this is what we use for our course materials. And if you were brave enough, you can go click on this link and you'll see that we have something like 1,570 changes that have been made to the course materials since the course was moved to its current format. It's been a while now. But every time we make a change to the course materials, we save that change so that at any point, if we want to go back to what we've had in the past, we can do that. And we do it not by changing file names, but just by saving what has changed each time we update different documents. But yeah, the most obvious reason to sort of embrace this idea of version control is like what's illustrated in the comics above, to keep track of the full history of changes to a document in a systematic way. And if you're really organized, you can do that by renaming your files, but it just generally will break down pretty quickly for most people. The point here when you're dealing with software is that you're going to have something that's kind of like a living document, which could be your Jupyter notebook. You're making changes to it, and at some point you might make changes to your document where like your code that worked before no longer works. And if you want to go back to when it worked before, sometimes you can do that by undoing what you've done. But other times you're like, you break something, you're frustrated, you close your notebook and save the file, and then you open it 2 days later, and you're like, right, it's still broken. This is kind of meant by learning some ideas of version control to help you avoid that situation, because if you can go back to when it was working before, you can save yourself a lot of stress. For us, we're going to be using a version control system called Git. You probably already know from the GitHub name that this is something that is one kind of version control. GitHub just combines this version control software Git with a sort of social coding element. And Git's a software package that was developed by Linus Torvalds, who's the creator of Linux, kind of famous guy as far as software goes. The basic idea with that is like when you're developing software, you want to keep track of the changes, especially when you start working with things where multiple people are making changes to a single piece of software. So seeing not only what changed, but who did it, and being able to say, that was a bad idea, I'm going to undo that change. That becomes really important when you start working on these bigger software packages. But the idea with Git is essentially it takes snapshots of your software whenever you choose to issue the command that says you want to save things. And it's one part of GitHub. So we'll talk about how Git works in just a few minutes. GitHub, as I mentioned, is built on Git and it relies on Git, but it has also this kind of social piece to it. So by sharing software on GitHub, you open it up to millions of other software developers who might like to get involved in helping you work on your software project. For our exercises, for example, we're making private repositories on GitHub so that only you and the course instructors can see them. So it's not like you have to open up your homework to millions of people to be able to look at it and criticize what you're doing. But instead, the idea is that you learn how to use GitHub so that if you want to work on software projects using GitHub in the future, or if you want to make your own software and open it up for other people to use, that you can do that. And that's a great thing as far as kind of open science goes, because more and more you're being asked, if you're developing software for scientific applications, to provide access to the software so other people can see not only your results, which could be the nice plots you put into some article, but how did you generate those plots? What was the software that was used? And then people can reproduce your results. They can modify what you've done. And by learning, again, how to use GitHub, you're kind of putting yourself in a position to be able to easily do that, whether it's in the form of a thesis that you write or in something else that you choose to do. Like if you just become interested in programming as a hobby, knowing how to use GitHub will quickly become something that's quite useful. It's also handy because it provides a place for you to put documentation about your software, which again depends on how complex your software is. But documentation, of course, is the most useful thing for normal people to be able to understand what your software does if they don't want to go and look at how the code operates. So putting this kind of code and the social piece and the documentation together in one place is a really helpful thing. And there's a handful of different tools that go along with working in GitHub that can be helpful. Perhaps most notably issue tracking. So when something is broken in the software, there's a place where people can open an issue and say, here's what the problem is, and then it tells you, that something should be fixed or improved in the future. As far as vocabulary goes, there's a few things that are useful to know. Probably you've already heard us referring to things like repositories. So it's basically where you store your files for a given software project. So for your exercises in the course, you'll have an exercise repository, which is where your exercise files, like your notebook, are stored in GitHub. A commit is essentially when you decide to save one of these snapshots. It's called a commit in Git terminology. We'll come back to that in just a minute. Then there's revisions or versions, which is a specific one of those commits so that you can kind of check in the past what's happened. Cloning we've already done for the notebooks. That's just taking a copy of a Git repository, including all of its tracked changes. And then there's these operations called pulling and pushing that we'll come to in just a minute, and merging, which we'll hopefully be able to avoid because merging is not nice. So let's talk a little bit about what Git does and get you kind of activated a little bit to do something with Git. In this lesson, we're going to cover basically four things. One is how to clone a repository from GitHub. We've already done that in the example for the notebooks earlier, but maybe you didn't really understand what was going on because we hadn't talked about Git at all. Then we'll talk about how to add some changes, how to commit the changes that we've added, and then finally, how to push the changes, for instance, from the CSE notebooks to GitHub. Because what we did for the first exercise, like uploading a notebook, is, you can do things that way, but there's a more efficient way to do things with working with Git. We will be using this JupyterLab Git plugin, but it's broken in our CSC Notepad environment at the moment. So I'll show you how to do this in the kind of old-fashioned way, and we'll fix the plugin, and then you can follow the instructions here, but it'll be easier to use than what we're going to do in our first testing of how to use Git. But we got to cover a couple other concepts first before we get into the kind of actions to take. So first off is just kind of a picture of what a Git repository looks like when we have something, for instance, like files on GitHub. and then files on the CSC Noppe system. So we have this remote repository, which is our files that are stored on a server, for instance, on GitHub. The notebooks repository that we use for the weekly lessons is a good example. And then in the first week, you might remember we had to do this git clone operation. We did it using the little plugin in the CSC Noppe system to essentially download a copy of the files from GitHub to the CSC notebooks. And in this case, when you clone, you grab the files, but you also get the revision history to all those files. So if you were kind of knowledgeable as far as Git goes, you could go and actually look at the history of changes to those files in the GitHub repository on the CSC notebooks. But the cloning operation is a typical first step. You find a cool looking software package on GitHub, you want to get a copy of it, so you clone that to your local computer or clone it into the CSC notebooks. Then you work with it, maybe you make some changes or whatever, and you decide, okay, I want to update things like if you're working on your own exercise files, you'll make the changes to the exercise. You want to put the changes to update the files on GitHub. That's called pushing in Git terminology. So you push the file changes up to the remote repository. And then there's this operation that once you've cloned things, you can pull down any changes that have occurred in the remote repository. So when we updated the lessons for the notebooks for today's lesson, you click that little cloud with the down arrow. That was the pull operation in Git terminology. So it's pulling down the changes from the remote server. And when you want to make changes to the remote files, you push them up. That's the kind of terminology that's used there. With a little bit more detail of what's going on, we can look at this picture. So if you have a copy of some files from a Git repository on your computer or in the CSC Noppe environment, you could be making changes to the files, and depending on the software you're working with, there could be hundreds of files that you could be modifying. So this git add operation is typically the first thing where you say, okay, I've got some changes I want to save. Git add is used to indicate, for instance, which files you want to update, because maybe you don't want to, like, you've tested something out in a bunch of different changes in certain directories, but there's only a few of them you want to update. Git add puts these files you've modified into what's called a staging area, which is essentially like a place where you're saying, okay, I'm getting ready to save these updated files in a Git commit. It's kind of like a rough drafts, if you want to think about it that way. Again, this might make more sense when we work through it, but let's go through the kind of description of how things go first, and then we'll get some more hands-on experience. So once something's in the staging area, you can then issue the command git commit, which actually will then save the snapshot. So at this point, when you've added something to the staging area, no changes are yet saved. Only when you run the commit do you save the changes to your repository. So at that point, you then kind of have taken a snapshot of the files in the repository. And from there, you even still would want to then push them up to GitHub, for example. You can commit things without pushing to GitHub, but then it won't update the files on GitHub. So if you do your exercise and all you ever do is git commit locally and you never push, it will be updated in the CSC Noppe system. But we can't access your files in Noppe. We can only see your files if they're pushed to your GitHub repository. So this is the kind of overall picture of how things work in Git. It's probably very abstract right now, and that's fine. We'll get to the more kind of concrete examples here. So we're going to work in the CSC Noppe for this, but before we can get to actually pushing or making any changes, we need to do something on GitHub, which is to create a personal access token. GitHub, for security reasons, doesn't like to use your username and password as a combination for how you authenticate to push files to GitHub. It uses instead these personal access tokens because, unlike your password, they are sort of like disposable things. So if something happens and you accidentally, share what your personal access token is, you can delete them very easily without affecting your GitHub account. Obviously, you don't want to have to delete your whole account if you accidentally share your personal access token. So for instance, in today's lesson, I'm going to make a personal access token. It's going to be in the lesson video and someone could see it, but I don't care because I'm going to delete it as soon as the lesson's over. So there's no risk that someone could go and modify files as me in GitHub. I'll probably still blur it just because I'm paranoid, but in essence, these are kind of disposable things that allow us to identify yourself as your user when you make changes to GitHub, but without using your password. So to get started with this, you need to first go to GitHub, and then I'll make that a little bit bigger. And if you're not logged in on GitHub, you should log in. That's a good thing to do. Oops. And I just need to get my iPad on Wi-Fi so I can follow along on there. All right. So on GitHub, once you are there, you can go to your, if you put a picture, your picture or whatever shows up in place of that picture on the top right, and click on that. And then go down to settings on the list of things that come up in that drop-down menu. So you can click on settings. And then on your settings, if you scroll all the way down to the bottom on the left side, there's developer settings, which is what we're going to use for this part of the lesson. So you can click on developer settings and it pulls up this thing, where over on the left side you can see personal access tokens, which we'll click on that, and then we want tokens classic in the drop down from there. And if anybody has trouble at any point, just maybe raise your hand and Kamyar can give you some help. But are we okay so far? Anybody not okay so far? Okay. So I already have a token here. This is like my normal token I use for, I just make a new one every year for doing my GitHub stuff. But I'll make one for the course as well, and you can make one for the course at the same time because that's how we'll save our changes to GitHub. So to do that, we can go to generate new token, and then we're going to do generate new token classic. So you can just click on that. And now at this point, if you're using two-factor authentication, which is recommended, you may be asked to enter a like a authentication code, or I have to enter my passkey because I'm using that, even though I don't know what passkeys are. It's like, I guess, the more secure way to do things. So I've just authenticated myself like that. But yeah, you may have to do a different, like, extra level of authentication before you get here, which is where we're going to make our token. And first off, we can give it a name. So let's call it Geo-Python 2024. You can call it whatever you want, frankly, but it's maybe makes sense to like not call it your dog's name or something, but give it some kind of more meaningful name. And let's set this token to be valid until the end of the year. So I'm just going to change the expiration to custom. And then I'm just going to click over here to 31st of December, because most likely everything you need to do in the course should be done by the 31st of December. So it's safe to say that let's just have that token expire at that point. It is possible to have them not expire, but again, as far as security measures goes, Git recommends having an expiration date so that should this token somehow fall into somebody's hands, they can't make changes to your files as you. So set the expiration date to the end of the year. And then there's this selecting the scopes, which we won't go into much detail, but essentially it says like, what powers do you get when you use this token? And we want the powers to be able to modify things that relate to our private repositories, because that's what our exercise repository is going to be. We want to have this admin repo hook. and I think we want delete repo as well. Those should be the permissions you need. So it's 3 in total. It's repo, admin, repo hook, and then delete repo. And at that point, you can click generate token, and you'll get this string of text here. This is the only time you will see this string of text. So I would advise you at this point to copy it and maybe paste it into a text file somewhere or someplace on your computer that's a sort of secure location. If you use a password manager, for example, you could put it in there. That'd be a great place to put it. I'm going to leave this open like this because I'm going to come back to here just to copy this for the sake of simplicity, to not have to jump between different things besides the web browser. But if you click the little couple squares here, it will copy this into the clipboard, and then you can paste it somewhere. Again, you won't see this text again. Like if I go away from this web page and come back, it will not show me the contents of this token. So it's kind of a one-time thing. If you need to, like if you forget it or you delete the file that you saved the token in, just make a new one. Delete the old one and just make a new one because they're disposable like that. But yeah, it says here, make sure you copy it. You won't be able to see it again, and that's true. Once you navigate away from this page, it's no longer visible to you unless you've saved it. I think I've made the point. Okay, now that we have our token, we can go to our exercise 1 repository and do something with this token, like download a copy of the exercise to our CSC Noppe environment. So back here in our meet get lesson, we've now created our token, and now we're going to use it. And you could, for instance, go to the Geo-Python 2024 GitHub organization and find your exercise 1 repository there. I'm going to click this one because I have a link directly to my repository on the web page. And when I click that, it takes me here to my copy of exercise number 1. You might notice that there's nothing that's happened here because I haven't done my homework. But you can see a couple things here. One is that it's private. So if you click that link, my guess is you get some kind of permission denied message. But if you take the URL for that link, if you just copy that, for example, you can put in your GitHub username after the exercise 1, and that will take you to your GitHub repository for exercise number 1. Otherwise, you can just go to the Geo-Python 2024, and I think you'll only see the exercise 1, maybe exercise 2 public repositories, but then you should see your private copy of exercise number 1 there as well. I would do that, but I think I'll see then everybody's exercises because I have permissions to see yours, and I think we'll just avoid that. Yeah, also when you accept the assignment, you should get the link that way for exercise number 1. So, but here, now what we can do is we want to get a copy of this onto the CSC Noppe system. And to do that, we need to copy the address for getting the code. So if you click the blue code button here, you can then copy the URL to the clipboard, which is the URL that we want to clone to make a copy of our exercise. Here's where we're going to deviate from the lesson a little bit. So if we go back here to our Jupyter lab that's running on CSC Noppe, normally I would send you to this GitHub plugin. I would have us navigate, for instance, here to the My Work folder, go to the Git plugin and click Clone a Repository, but this won't work. At least it won't work right now. We should be able to get this working later today. There's a problem with this plugin currently. So we're going to have to do things the kind of old-fashioned way. And to do that, you need to go up to File, to New, and then select Terminal. And when you click that, you then get this terminal window that pops up. So for those of you who have used these kind of things before, this is the command line interface. It's essentially a way in which we can interact with the computer that's running this CSC notebooks server by typing in commands to basically tell it what to do. So instead of clicking buttons, we're going to type things in. The first one that's useful is a command called ls, which essentially will just list all the files in the directory where you are right now, and you should see both a my-work and shared that show up when you type ls and hit enter. And our first thing is going to be to do cd and then my-work, which is going to change the directory. So right now we're in the home directory of our server that's running, and we're going to change directories into the my-work directory. So you do cd my-work and hit enter, and then you can type ls again if you'd like, and you should see that there's one folder. You can't tell it's a folder, but there's one thing there called notebooks. Does everybody see notebooks? There, yeah. So what we're going to do now is we're going to clone our exercise number 1 into this my-work directory, because then it will be preserved on the CSC notebooks or the CSC notebook system in the future. So the way for us to do that is, instead of clicking buttons, we're going to type in git clone. And then I'm going to paste here what I copied earlier, which is the location of my Git repository when I was back here, wherever it was here. When I copied this thing, I'm now pasting that URL in here. Then when you hit enter, you're going to be asked for some information. So it says it's going to clone into this directory, and it says username. This is your GitHub username. So for me, it's Dave Whip. All lowercase in my case, if whatever your GitHub username is, and I think it is case sensitive, so you should type it in with capital letters or lowercase letters or whatever you used. Then you're going to be asked for your password. This is not your GitHub account password, but instead this is the personal access token that you just created. So if you have, yeah. Okay. Yeah, another question. It says it's, did you, when you copied it, did you have in the URL like your GitHub username also, or was it just the exercise1.git? Yeah, so that what you copied is the public template, but you need the one that has also your GitHub username, and there you should be then asked for your GitHub username and password. So yeah, that's a good thing to check. You should see that when you go to copy this, that it has your GitHub username at the end of the, minus then username.git. And then now it should prompt you for your username and password when you try to clone that. Yeah. So now it's sitting here waiting for the password. I'm going to go back to my personal access token because I still have it up here. And I'll copy that one and then paste it here. And when you paste, you won't see anything written to the screen. So this is, again, something that is a common point of confusion. You paste something in, you expect to see either the cursor move or at least something. It won't show anything on the screen when you do that. But if you press enter, if you've pasted in your personal access token, you should now see output like this that says enumerating objects, blah, 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 removing or receiving objects, resolving deltas. And if everything worked okay when you type ls again, you should now see you have another directory in here, exercise1, and then your GitHub username. maybe by show of hands, how many were able to get that to work? So like, okay, not super impressive numbers on that one. So, yeah.
I was a little bit hasty and I basically copied it from the exercise 2 folder where just that file for the weekly exercises.
Okay.
Should that work as well? It seems to work so far.
I think the question would be if you go into that directory, like if you open it up inside the file browser in Jupyter Lab and then go back to this Git plugin, do you see it pop up with this information about current repository? Or does it say like still show the buttons to create a repository?
Well, I already cloned that one, so when I got that.
So you cloned it.
I also, like as you did it, I also cloned that new one, but I also have that one that I was already working on.
Okay.
It's in a different folder currently, but I can probably just copy paste it to that correct repository.
Yeah, I think if you copy paste the files, because the only thing I could think of is that it might not have the Git information in there. It might like have the copy of the files, but then not have the kind of information about Git. So then, yeah.
Well, I can probably safer if I just copy paste the code.
Yeah, I think so. Another question?
After you clone it, can you move the folder?
Yeah. Yep. Yeah, I mean, the most important thing is to make sure it's inside the My Work folder, but you can rename it. In terms of the structure in Git, there's actually like a hidden directory called .git inside of the folder. So if you rename the folder, it actually will still refer to the same location from where you cloned it. It doesn't know anything about the fact that you've changed the file name or the folder name locally. But the .git folder contains all the information about the history of changes and also like where to push changes like on GitHub. So yeah, you can rename it if you like. You could make it, for instance, an exercises subdirectory if you want, and then move it in there, or however you want to organize things is totally fine.
Yeah, is it supposed to be empty, like when I open the...
Exercise 1 should be having at least one file in there, if it copied correctly.
Sorry.
Is exercise 2 template empty?
Shouldn't be. No, I mean, there should be files there. There should be at least a notebook and a git ignore. So again, how many of you have managed to clone your exercise number 1 repository? Again, just by show of hands. So everything we're doing right now is easier to do with this plugin, but it's the same steps essentially. So if you're having trouble, don't panic because we'll have more opportunities to work with this in the exercise for this week. You can also ask questions in Discord. You can go to the help session on Thursday or Friday if you're having problems to clone things or your personal access token is giving you headaches or whatever. But yeah.
Just wanted to ask if we get weekly feedback on the assignments we upload on GitHub or how does it work?
Yeah, so normally it would be the case that it's maybe a week and a half or 2 weeks after you turn them in. Or no, so after you turn them in, I guess it should be like about a week, within a week that we should give some feedback. I mean, it'll just be like, you know, which points you got for which problems, and then like usually it's a couple sentences of just kind of quick, like, you know, if you had an issue with something, like describing what to do differently.
And it pops up in the temporary repository and upgrades in GitHub, right? And there it's gonna be like about the README and about my solution is gonna be a bit of it.
It'll be in the README at the bottom of it. There's like we just basically add text to the bottom of the README file that like says like, here's the summary of the points you were given on this exercise.
Okay.
So.
Like entering a new repository for every exercise, right?
Yeah, that's right.
So am I gonna overwrite the solutions or is it stacking?
Yeah, so it's a separate repository entirely for each exercise. So it will be like the exercise -1 dash your GitHub username, exercise -2 dash your GitHub username. Each one gets its own repository.
So in the end, I have like, let's say, 10 assignments or exercises I handed in, so I also have 10 repositories.
Exactly.
For each assignment.
Yep.
And I get hand in my feedback respectively, and then I get the solution.
Yeah. So the feedback is given inside the repository for each person's exercise. Yeah. Okay, so I'm going to assume that most everybody is having things working, and if not, we'll alert Kamyar that you're having some issues, and we can move forward a little bit because we do need to at least get through how to save changes and how to make changes so that you know how to do that. And it'd be great if we had just a short bit of time at the end to quickly introduce this week's exercise. But now, when I type ls, as I did before, I can see here I have this exercise 1 Dave Whip directory, and I can actually do cd, and then if I type ex right now, since I only have the one exercise, and it's the only thing in here that starts with the letters ex, I can hit tab, which will then auto-complete the rest of the folder name. You can also just type this whole thing in, but hitting the tab key will be a kind of shortcut to fill in as much text as it can. If there's multiple exercises in there, it will kind of fill in till it reaches the point where there's some character that differs. But I'm typing cd, and then the name of the exercise folder. And then if I type ls in here, I see only that I have this readme.md file. It's quite possible for you that you'd see you have the readme.md file plus your notebook from the first exercise. If you did that already, then you should see that notebook is there, because when you copied it, you copied both the readme and the notebook file. Of course, since I didn't do my homework, I have only the readme file here. Similarly, if I'm inside the Jupyter Lab environment here, I could go into the exercise 1 directory in the Jupyter Lab file browser, and I could actually double click on the readme file, for example, to open that up. And this is the readme file that was going along with our exercise, just giving instructions of what to do. Yeah?
Is it possible to get this one in the layout of a cell Jupyter notebook, or does it have to be like this?
I think in Jupyter Lab, I think the markdown files are only rendered as text. I don't think they make them nicely formatted like they are on GitHub. You could copy paste this into a markdown cell in a notebook and you would see it nicely, but I don't think there's a way to render this. I don't know what Preview with Lumen does.
But when I, for example, I open it with like ES Studio or something, I get the
Yeah.
normal Jupyter notebook layout, right?
Yeah, so this is basically just we'll practice with this markdown language, but it is essentially just a way of making fancy looking text in a plain text document. So there's things like these headings that are indicated with this number sign, that if you open this file in Visual Studio Code or PyCharm or any other kind of developer environment, most of the time it will recognize, oh, this is a markdown file, and then format it nicely. Same way it is on GitHub when you go and see the file on GitHub. But the source file of what is producing that just is a regular text file here. So it looks, unfortunately, in Jupyter Lab like this. There probably is a markdown plugin, but we don't have it in the environment. But I'm going to get rid of this successfully cloned thing here. Our job now is just to make a change to this README file. So if you just go to the bottom of it, you can type in something like, if you want to add a heading here to say, check it out or whatever. And then I made a change. To celebrate the fact that you're modifying your file. You can put whatever you want there, like maybe not something offensive, but like it's just, something, I don't know, just to make some change to the file. So now I've typed something in, and you can either go here to File and hit Save Markdown File, or you can press, like on a Mac, Command S, or probably it's Control S in Windows to save this. This has now saved our file change locally on the CSC notepad system, but we have not made a commit in GitHub. We have not done anything Git related yet. To do that, we have to jump back to our terminal window. Again, this is a lot easier when this little plugin is working because we don't even have to leave this view. But now we're going to jump back to our terminal window. So again, if I type ls, I see I only have my one file in here. And if I type git space status, this will tell me what Git thinks is going on right now in this directory. And so it tells me that there's a modified file here called readme.md, which means if it shows up as modified, Git knows it was something where the revisions were being tracked before, and something has changed in the file locally. Then it gives me this untracked file, this .ipynb checkpoints. You can ignore that one. But we have a modified file, and let's say that we want to save these changes to our file. Again, our first step is to put it into this staging area, a kind of rough drafts area. So we can do that by typing git add and then readme.md. So now we're putting it into the place of like, yeah, we're ready to save this change. It's staged and ready to go. So you type that, you don't get any output to the screen. But if you type git status again, what you see here is now you've got changes to be committed. So to be, not yet committed, but to be committed. And the modified file now shows up in green, as in it's ready to be saved. Yeah?
When I typed in git status, it's a actual Git repository.
What directory are you in? Is it like if you type, for instance, pwd, it will print your working directory. Are you in like the mywork/exercise one, your GitHub username, or just like the mywork?
No, that's my username also.
Well, yeah, we can check, but it seems maybe it's missing some. It's maybe missing something. Yeah.
For me as well, when I did git status, it said that my branch is on today, and nothing to do with it.
Okay. So did you, when you modified this README file, for example, did you save it?
Yeah, control S, save.
Because normally if you then go to that directory and type git status, it should at least show what it did before, that there's a modified file. Can you tell, like when you look on the readme.md, does it show like a kind of black or dark gray circle here, or does it?
Yeah, now that I've changed it, and I've saved it,
Uh,
so when I went back to this file,
so you've added something to it. What if you just go to File, Save Markdown File? Does that do anything different? Because it should show up at least indicating that it can tell something has. Yeah, we can check it after. I don't know. That's weird. It should normally detect that the file changed from its original version, but yeah, we can take a look. So for those who have gotten to the point where, like, when you type git status, it shows that there's a modified file here. Our next step is to actually commit our changes, which we can do with the command git commit. And then we're going to give this -m, which is our commit message. So whenever you save changes to GitHub or to Git in general, you should give a message that essentially summarizes what you're changing. And these commit messages are actually quite useful because oftentimes when you're looking to see something you changed, you can scroll through those messages and say, oh, okay, here's where I worked on problem 2. And you can check by looking in the Git history on GitHub what you did when you changed it. So for instance here, we could say added a new section with some comments or whatever. It doesn't. In this particular case, this is kind of a toy example. It doesn't really matter. But this message is essentially our log of of what we changed. When you're working on the exercise, you might have a commit message that says something like, finished problem 2, or, finished first half of problem 3, whatever, that tells you kind of what changes you're actually saving. So when I run this, I get this message that pops up and says, wait, not so fast. I need to know who you are before we can save these changes. And this is because every time Git saves a commit, it also saves who was the person who made that change. Because it is designed to be run in a distributed way that multiple users could be working in the same Git repository, we have to define a couple things here. So I'm going to copy the text here for this git config global user email and replace the email address here with my Helsinki email address. So this now gives that, and I'm going to copy the other thing here for the git config. Paste it here and then just replace the your name with my name. Every time a git commit gets made, it's going to show what time it occurred. It gives a unique hash or a set of characters to identify that particular commit. It shows the name of the person and their email address, so that if there's a need to contact someone about what went on, of course this was designed at the time when everybody was using email. Now, I don't know if you were to make Git today, if you'd use, use a phone number or something else, Instagram tag or handle or whatever, but it's email and username. So this then defines the information that Git needs to be able to make the commit. And if I press the up arrow 3 times, it kind of just goes back through commands I've typed in already. I can try this git commit command again. So git commit, and I have added a new section with some comments. And now when I run that, I can see this is actually the unique set of characters that is the git hash. And there's the comment that was made, 1 file changed, 5 insertions, which I think is the 5 blank lines or 5 lines of stuff that have been added to the file. And now we have made a change that's tracked in Git locally on the CSC Nope system. We've got one more thing to do in order to save this change on GitHub, and that is to actually push the commit from the local CSC Nope up to GitHub. If you happen, like I am right now, to be in the Git plugin over here, you'll see that when I did this commit, it popped up with this orange little indicator thing next to the push, indicating that we have changes that could be pushed up to GitHub. Unfortunately, if you try to push those changes, you'll see that it doesn't work. Actually, don't even bother, because it's going to ask you for your Git credentials, and I'll tell you it won't work, so don't need to do that. We have to push our changes manually. So for this, we can now type git push. When you do this, again, you will be asked for your GitHub username. So I'll put that in. And just like before, it's going to ask you for your password, which is actually your personal access token. So you'll want to go copy that. So I'll copy it here, paste it, and hit enter. If all goes well, you should see some information indicating writing objects, total 3, remote, resolving deltas, blah, blah, blah. And it's pushed it now to my exercise 1 repository. So I will just show you quickly here that now if I look at my exercise 1 repository, since I have the tab open, I can see previously there was some commit message here, and if I refresh, I now see my username, added a new section with some comments 2 minutes ago as the most recent commit. How many of you were able to do that? Okay, better than I thought. So I'll tell you, using this little plugin tool makes things a lot easier, but the process is identical to what we've done. So you would clone something like your exercise repository, make your changes, add the files that you wanted to change to the list of things to be committed, make the commit, and you'll see when you use the plugin, if you try to commit changes, it will give you a little space where it says you have to put a commit message. And then once you do the commit, you can push the changes up to GitHub, and things kind of proceed like that. But yeah, there's a question.
Yeah, just a general question. So the workflow for the following assignments is that we type in our solution in the existing exercise notebooks.
So you clone it, like you basically use the little link from the web page to make a copy of the exercise, then you clone it to the CS Nope. You make your changes, and then
I push it up back to GitHub. And
yeah.
then when I go into this repository, I see the formerly known readme file now added with my solution update.
Yeah, that's right. I mean, or your notebook will be updated, and you'll see like your answers have been added in there. So like, if I scroll down now, I can see, for instance, at the bottom that I have this check it out, I made a change message at the end of my readme file. So the kind of workflow is essentially clone, make your changes, commit the changes, and then push them to GitHub. And the kind of key part of that is pushing them to GitHub, because once you do that, then we can see your solutions. If you don't push your changes, they may be on the CSA Nope system, but we can't see them unless they're pushed to GitHub. So that's maybe the important thing to remember.
Show it again.
This, yeah.
Is the plugin going to work in the future, or that's what we're doing?
Yeah, the plugin should, I think we can fix that today. I know what the fix is, I just couldn't implement it last night. So that was the first time I actually tried cloning a private repository, and that's the only place where it doesn't work, is with private repositories. So that was a bit of an unfortunate surprise. Okay. I understand that not everybody might feel 100% confident in things working right now, but that's okay. We have possibility to answer questions in Discord. You can also catch us after class if you have individual questions, and you have Thursday and Friday for the kind of exercise sessions where you can go if you're having problems. The course assistants can help you out. We'll put a message in Discord as soon as the Git plugin is working, which again will just streamline things a little bit. It's really easy once you get that working to just build this into your workflow, that when you want to save your changes, you kind of automatically will add them to GitHub. And the documentation on the course page now describes how to do this with the Git plugin. So I think you'll be able to kind of put together what to do without too much trouble. But if you have difficulty, let the course assistants or one of us know. But in the interest of time, I think we'll go forward here to talk about a couple other things. As I mentioned, the instructions about how to use the Git plugin are on the course page, so you can find those there. And what we did was the kind of Git from the command line example, which hopefully you won't have to do again after today's class. For me at least, I still do everything in Git from the command line. I don't like using the plugins for any of the stuff. I pretty much always use the Git command line, but that's just because that's how I learned to use Git. And it's like, if I learned again, I probably would use the plugin, but I don't know. Can't teach an old dog new tricks, I guess. There's also a couple notes here about resolving conflicts at the end of the lesson, but we'll deal with those as we come to them, because if you get a merge conflict, it's best to just get some help from one of us. They're not necessarily easy to fix. So a couple other things. We're using this Classroom for GitHub thing that you already saw last week. Essentially, it allows us to set up assignments, and then you can click a link to make your own copy of the assignment. So it might have some starter notebook, like we will have in this week's exercise. It might have a README file describing what to do and things like due dates. And it's a template that you can work from to modify it to turn in your exercise. So you'll see on the course page this kind of section for exercise 1, exercise 2, whatever, where you can click this link, to accept the assignment. That makes your personal copy of it. And then you'll go through the process of cloning that one and working with it on the CSC Noppe system. So we've already done that a little bit, but if you're unsure about that, you can have a look at the description on the course page here. We also have a good coding practice that I think I will very quickly say a couple things about, but mostly leave this to you to read through if you would like, because we're going to run out of time. And essentially this good coding practice is about describing your code. So we had last week something about variable names. We gave you some tips about useful ways to name your variables. This is about code comments. And in essence, we are going to expect you to leave comments in the code describing what you've done, because although it might be clear to you in the moment, it may not be as clear to us, especially if you've tried to do something and it didn't work. If we can see in your comments what you were trying to do, then we can give you more useful feedback about how to fix the thing you might have gotten stuck with. And these code comments are a really useful thing for people who are looking through things, even like your notebooks, to kind of see what you're doing. So there's two different kinds of comments that are described in this good coding practice. One of them is a line comment, which starts with this number sign. Anything that follows that character in a code cell in a Jupyter notebook or in a Python script file will be ignored. So this is basically for you to put notes in about what you're doing. And it's often useful to put line comments in anytime you have like some group of operations that work together. So you might have something like, later in the course we'll make some plots. You might have a line comment above the plots that says, create plot of whatever, temperature data. Just describing in normal everyday language what you do. Our request is that you give these comments in English, just because although for you personally it might not be your first language, if you share software on places like GitHub, the odds that you come across someone who is like able to understand code line comments in Finnish or some other language are lower than if you put them in English. So the kind of common practice on GitHub is to put code comments in English, just because that's the kind of easiest common language among people who would be using GitHub. And it's a good practice to get into just yourself, because you don't know. Like, you might start out thinking, well, these comments are only for me. No one's ever going to look at my code, but who knows? Like, you may end up sharing things in the future. And if you just start by putting in the comments in English to begin with, it can be easier. We're not super harsh on this one, but it's something that we might comment on in the feedback for the exercises if you're giving comments in some other language, just to say, like, we encourage you to put the comments in English as a kind of good coding practice in itself. So there's a few examples showing how to use these line comments. That's the kind of most common one you'd use. And there's also another style of what are called block comments. So those you start with a triple quotation mark, and then anything that goes between the first set of triple quotation marks and the last will be ignored. So these can span multiple lines. We'll deal with these kind of block comments in later lessons, like especially when we start talking about functions. We'll talk about these more. But you can have a look through the good coding practice if you want some additional information about commenting on your code. Which takes us to our almost exercise topic about working in pairs. So for those of you who have not filled in the pre-course survey thing, please, if you have a request, most especially about like if you want to work with someone on the exercises in the course, it'd be good to fill in that pre-course survey as soon as possible, because we are going to pair you up with someone else to work on the exercises. If you have a request for who that person is, you can put that into the pre-course survey. But the idea is that we'd like to, especially for the first 4 weeks of exercises, give you a partner to work with, so that when you're having problems with some of these technical things in the course, if you're confused about like some of the syntax and all this new stuff that's coming to you, you've got someone else you can talk to as you're working on the exercises. And this is actually a programming practice that is used by even kind of more experienced programmers, where you just have someone who's kind of looking over your shoulder as you're coding, And that person catches a lot of the little syntax errors. Like when I typed in today station names instead of station types, and somebody said like, oh, don't you mean station types? Those kind of things get caught by someone who's just following along. And the same thing works when you're programming at the beginning, like, oh, you got to use the parentheses instead of the square bracket there, or whatever. These little things will save you a bit of frustration to have somebody that you can talk to while you're working on this stuff. So the idea is that we pair you up, and for each week there's going to be one person who is the driver and one person who's the navigator. And it's just like rally car racing. This is about the extent of what I know about rally car racing, is that you drive on these dirt roads and the car goes kind of fast. But I also know there's a person who's driving, there's a person who's kind of talking to the driver, saying, hey, there's a sharp turn coming up, or these are the things, like the navigator's playing a role. The navigator's job in the kind of coding thing is to sit there next to the person who's driving, who's typing in the sort of things to the exercise, and just keep an eye on how things are going and note if there's kind of little syntax mistakes, or if you've got some question or thoughts about how things could be done differently to answer some part of the exercise, then you could be talking with the driver. But we're only going to grade the driver's exercise each week. So if you're the navigator that week, you only have to turn in one exercise as your pair, which is the driver's exercise, and we'll grade that one. And then the navigator, you can do it if you want yourself. Some people like to do the exercise themselves as well, but we only grade one copy, and that's the driver's exercise. So it'd be good to make sure you get in touch with the driver, so if the driver doesn't do the exercise, you don't get penalized. But we'll try to help out with getting you guys paired up with somebody. And if you're not having any communication with your partner, then we can try to fix that. Because sometimes there are people who are registered for the course who disappear, and we don't want you to be left alone. But anyway, that's the kind of overview of how we'll work on the exercises. You'll be in partners. We're going to grade the driver's exercise, and we will later this week, probably tomorrow or Wednesday, put the list of drivers and navigators up on Discord so you can see who's the driver and navigator for each week. You'll also have the person's information to be able to contact them, and I think if all goes well, the process has worked pretty smoothly in the past. We kind of push you to be partnered up for the first 4 weeks, but after that, you can assess with your partner whether you want to continue to work in a pair or whether you want to split off and do your own thing. But yeah, that's that. So then exercise number 2. Let's take a quick look here as we are getting short on time. As you might imagine, exercise number 2 is about lists and indices, which is basically the topic for our Python lesson today. We've got 3 problems, and we're giving you a notebook to start from in this week's exercise. So when you clone it, there will be this exercise 2 notebook that's already there for you to work in. Please don't rename the notebook. We use an automated grading system, and if you change the name of the notebook, it will not work. So in here, you'll find a template notebook, and you're going to see some lines in there that look like this, where it says your code here, and then raise not implemented error. Those are in the places where you should change and fill in some Python code to answer that question. You can just delete this text and then type in your code there. But it puts in this by default just to indicate that that's where you're supposed to put in your code. There's markdown cells also as well that would say something like your answer here, and then you could just delete the text that's there and type in your answer. Again, you can see this in the top of the notebook if you get confused. There's also this AI tool usage agreement where we basically just say that you acknowledge that you and your partner have followed the guidelines for use of AI in the course. For this exercise, we don't allow you to use any kind of large language model to generate solutions for the exercise questions, but in the future there are some places where we allow you to use things like ChatGPT to produce code, but not for this week. So basically you just say that you agree that you will follow the rules and not use ChatGPT. Our first problem in here, you're given a list of different FMI station names and the years when they first operated. So you have to make this list. So you have it here as a table. You're going to create 2 Python lists, one for the station names and one for the first years of operations. Then you're going to modify it by adding some additional station names and additional years of operations to your 2 lists. And then you'll sort them. And then after you've sorted them, you've got a couple questions here about answering what you have done. And maybe letting us know if there's things that have been confusing or if there's problems that you see. For problem number 2, you're given the list of monthly average temperatures from the Helsinki-Malmi Airport station. And this is a running average over the, I don't know, last however many years. But for this, you can see, again, a table where you have to put in the table as a Python list, where you have a list of months and a list of temperatures. And then you are given this thing that your code should print a statement that looks like this, that the average temperature in Helsinki in whatever month is whatever corresponding temperature. And in here, it's maybe worthwhile noting that there's places where you should make modifications to the code. And then there's also these test cells. So when you run these will let you check and see whether you've got the sort of right solution. So for instance here, there's an assertion test that says the length of the number of months should be equal to 12. So if you have more or less than 12 months in your list called months, it's going to give you a message that says you have the wrong length list. And the same thing for the average temps should have 12 values in it, 1 for each month. I suppose that makes sense. It also checks to make sure that months and average temp are both Python lists, and it asserts that this print statement, which you would define up here, should be exactly equal to this for the month of July. So it should print out exactly that string of text. Then at the end, you get a little bit of practice to work with this markdown, the thing that's used to make the README files. So you answer a few questions here, and then you can add in a picture just to show that you can add images to markdown files as well. So you can choose, for instance, I think you're asked to choose your favorite animal or something like that in this part of the exercise. And that's exercise number 2. Sorry for going quite close to 12, but are there any questions at this point? Yeah.
Do both of the people from the pair accept the assignment or only the driver?
Both can, but only the driver needs to. So again, if you want to work on it yourself, like if you're not the driver this week and you still want to do the exercise, it's totally fine to accept the assignment, but the driver is the one that needs to, because that's the, like, we're going to look for that person's GitHub repository. Yeah. And yeah, I think, are there other questions? Maybe we can talk about the grading of the assignment next week, because we use an automated grading system, so there's something we can show you. But if there's not any questions at this point, I think maybe we're done for today, and we'll see you guys in the exercise sessions on Thursday and Friday, and otherwise back here next week. So yeah, see you then.